Professor Dave here. Let's learn about reaction mechanisms.
He knows a lot about the science stuff. Professor Dave explains.
We've learned a lot about chemical reactions, but what is necessary for a reaction to occur on the molecular level? Collision theory states that molecules involved in a reaction, whether in the liquid or gas phase, have to collide in a particular orientation and with an amount of kinetic energy that exceeds the activation energy of a reaction. This is the amount of energy that has to be provided to allow for the reaction to proceed. Here, we can see that the two molecules have to collide in a particular way in order to react. Otherwise, they will bounce right off each other. As for energy, let's refer to an energy diagram. On these, up means higher energy, and to the right means later in time. So we can see that any reaction will have an activation energy, which is the kinetic energy that the molecules must collide with in order to reach the transition state. This is the orientation which, once reached, the reaction will certainly occur. Collisions with less energy than this will not result in a reaction. From energy diagrams, we can also see delta H, or the difference in energy between the reactants and products. If the products sit lower, it is an exothermic reaction which releases energy. If the products sit higher, it is an endothermic reaction and needs to absorb energy to occur. Most people would refer to a catalyst as something that speeds up a reaction. While this is often true, the better definition is that a catalyst is something that lowers the activation energy of a reaction. Because the activation energy is lower, many more collisions will result in a successful reaction, which is why catalysis typically results in a faster rate of reaction. Catalysts do not affect the delta H of a reaction, and they are not used up stoichiometrically in a reaction. In other words, one molecule of catalyst can facilitate many reactions, unlike molecules of reactant, which are used up in order to make products. Reactions also tend to have faster rates at higher temperatures, because more heat energy means faster moving molecules, which means more kinetic energy. At higher temperatures, more individual collisions will have sufficient energy to surpass the activation barrier. So the overall reaction for many trillions of molecules will proceed more quickly.